Hey, hello everyone. So I think everything working fine. So today we are going to solve today's daily leet code problem. So if you go to the leet code and find here in the top right corner, you will find this fire icon. So you will get a daily leet code problem from there. So today's problem is problem number 1861, rotating the box. Basically, what the problem says, you are given an M cross N matrix of character box grid representing a side view of a box. Each cell of the box is one of the following: a stone, a stationary object, obstacle, or empty. Okay. The box is rotated 90-degree clockwise, causing some of the stones to fall due to gravity. Each stone falls down until it's land on an obstacle. Okay. Another stone or the bottom of the box. Gravity does not affect the obstacle's position and inertia from the box, and rotation does not affect. Okay, it is guaranteed that each of the box grid return an n cross a matrix representing the box after rotation. Okay, so basically what it says that you are given a box. The box contains three type of cells. Either a cell is empty or a stationary obstacle or a stone. So what we have to do, we have to just rotate the box to 90-degree clockwise, and then the the stone will fall due to gravity, and we have to just return the box, like what will happen then. So if we go to the one note, uh, let's first draw a box here. Let's say this is the box, and we have cells here, so many cells. So here, mm, I think these are okay. Now let's make some cell, like these are stationary obstacles, so it won't move or something. And then we will draw some stones. Here, let's say one stone. Here, one stone. Uh, here, one stone. Here and here. Okay. Now, what we have to do? We have to first have to rotate this clockwise 90-degree. So we'll just rotate it. Okay. So to rotate this, like what we can do, we can create a matrix of, like uh, if the original matrix is of n cross m order, we will create a m cross n order, and then we'll just copy the values to its like the position where it will go after rotation. And then what we will do, we will just do kind of brute force thing, that we will came from the bottom, and whenever we will find a stone, we will drop it until it's reaches, like until it has empty cell in its bottom, we will just drop it. So like here in this case, if we take this cell, so it will go here and then here because the cells are empty. For these stones, it will go here, here, and as there are a stationary obstacle in the cell, it won't go any further. This ball or stone also go here, and then for this tool we will just drop it until we will find empty stills. So for this, it will go here. So after the gravity, we will have this uh, matrix, and we have to return this. So what we can do, we can just first rotate the matrix, and then after we will came from bottom, and whenever we will encounter a stone, we will just drop it until there are empty cells bottom of the rock stone. So here Let's assume box grid size and n is the column size box grid of 0 dot size. Now our answer will be of the like the resultant matrix will be of n cross m order. N cross m order. Now first we will rotate the matrix 90-degree clockwise. So for that, what we will do, we'll simply go in the like we will loop over the original matrix, and we will also v plus plus. What will it like the original matrix, uh, the ij cell. We will copy this value to the result of j comma n minus I minus 1. So what we are doing, we are just copying the value of original matrix to this, like uh, to rotate this, we just because if you see carefully the this stone is at 0 0. If we in this formula like 0 comma n minus I 0 minus 1, so n minus 1 it will go here, and similarly it will go here. So after successful rotation, what we will do, we will traverse each of the columns. So we will take one by one column and then place the rock in its the position after which gravity affects. So we will traverse columns one by one. So for that we will go J, and now what we are going to do, we are traversing. So we are now in the jth column. So what we have to do, we have to just go from the bottom in this column. So we'll go from I equal to n minus 1, I greater equal to 0, I minus minus. So if the current cell, that is resultant of ij, if this is not a rock, then we will just continue, because if it is a rock, then zil stone, then we will drop it in the bottom. And if it is not a stone, then we will continue. Otherwise, it is a stone. So we will just take a pointer, which is I. Now we have to calculate like how if we drop this, in which cell it will go. So if pointer plus 1 is valid, and like resultant of pointer plus 1 comma j equal to empty, means we are starting from the current cell, and then we are checking that how, like if we go in the bottom direction, how many empty cells are there, and then we will just simply swap the values, like swap result of ij with result of pointer comma j. So if there is no empty cell bottom of that stone, it won't execute. So we will just swapping the same element ij with ij. So in that case also it won't affect anything. So after that, if we just simply return the result, it should pass the samples. Let's check this. What it says that okay, I think we have, so original dimension is m cross n, resultant is n cross m. So we are traversing in the original vector, original matrix, and then, okay, so original has, I think m should be there. So yeah, it got accepted on the samples. Let's run on the actual test cases, and it got accepted. So let's see what are the constant here. Constant is very low, 500. So that's why it got passed. Like, if you see carefully what we are doing, we are just taking stones one by one and then dropping them in the brute force way. Like, so, like, is there any good way or like any optimal way to do this? So if you look carefully, if I make a copy of this, so just a minute. So basically, so I want to show this, like, why this approach is not optimal, because what we are doing is, like, if there are so many stones here, and let's say this, so in this case, like, first we will take this stone and we will drop this by this to this cell, then we will take to this stone and we will go finding this cell, and similarly for this stone we will traverse up to these cells and then we'll find this cell. So if you see there, if there are so many stones and so many empty cells bottom of that, we are traversing so much time. Like, it is a quad, like, if there are n, this size is n, and if there are a half n by 2 stones, then we are traversing every stone to n by 2 times, so the time complexity will be like quadratic for each cell. So it will be like row cross column square. Like, the time complexity will be like the size of the row, because sorry, the number of the columns in the result matrix, because we are going to column one by one, and then for each row what we are doing, we are just, in the worst case, we are traversing, uh, like, this will be the time complexity kind of. So it got accepted because the row and column got can go up to 500. So 500 cross 500 square it around some that. But we can remove this, like, eliminate this quadratic time complexity by two pointer approach. Like, one pointer will, 1 second, let me clear this. What will be our next idea for two pointer? Like, let's say here is a pointer. It is denoting the empty cell here. This is J pointer, and I pointer is pointing towards a stone. So then what we will do? We will just swap these values. So I will just take this stone and then move this to this. Now this J pointer will go up to the next cell, like where it is empty, and this I also go to the up, and then we'll do the similar process. So if you see carefully here, in the worst case also, like, the two pointer are traversing only once, so the time complexity will be like the number of columns into two times of the size of the row, the number of the row, which is equal to, like, we can ignore these two, and time complexity will be column into row. So this will be the optimized approach. So the two pointer approach. And what we'll do, if we have any stationary object, then whenever we will encounter any stationary object, we will just move this pointer to the up of the this. So that's the approach. Let's code this. So here also the same, like for we will traverse the column one by one. Then we will take a pointer, which will be initially at the bottom also. Now, what we are going to do, if current is not a stone, then we will continue, or we can do what, like while the pointer is greater than current value, and the pointer is not empty, because we have to find a bottommost empty cell. So pointer comma j is not equal to this, like we will reduce the pointer. So what we are doing here, until like the pointer is below the current cell and the pointer is not empty, we will reduce the pointer. And now if current cell is a stone and the pointer is empty, pointer and j is empty, then we can swap this. Swap result of ij comma result of pointer comma j. Otherwise, like otherwise, if we encounter any, like the current cell, if the current cell is not this or this, then if we encounter any like stationary object which is star here, we'll just simply make the pointer to this value. So this should work, I think. Yeah, it got accept passed on the sample. So what we are doing, we are like this I is traversing in the current cell and the pointer is, like the definition of the pointer is it will point to the bottommost empty cell which is available. Then we will just uplift the pointer until it find any empty cell, and then we will just check if the current cell is stone and this is empty, then we will just swap the values. And otherwise, if current cell is a obstacle, then we have to point like update the pointer to that value, because like no further, like no further stone can drop beyond the stationary object. So if I submit this should also got accepted on the main test case. So yeah, it got accepted. So here the time complexity equal to like the column size cross 2 into row, because we are traversing this is row cross column. To rotating the matrix, we are taking row cross column time. And for this traversing column one by one, we are taking column cross 2 into row. So the overall time complexity is row cross column. And space complexity will be order of 1 here, because like uh, we have to return this answer. So we are not considering this answer to any space. So that's all for today. So thank you for watching this.